omnipotent, all-powerful, capable of anything. That is the word we use. Not almost anything, not anything except just anything. So here's a question that sounds like a trick, but genuinely is not. Could an all-powerful being reach back into yesterday and turn a Wednesday into a Tuesday? Could it unsend the message, take back the spoken words? Could it reach into the moment your mother took her last breath and simply not allow it to happen? You might think the answer depends on theology, on faith, on which sacred text you were raised reading. It does not. It depends on thermodynamics, because there exists a law in this universe more stubborn than any other, a law that does not bend for rulers, for scientists, or as you are about to discover, for gods. And by the time this video ends, you will understand why altering even 1 second of the past may be the single thing that power itself cannot touch. Drop a ceramic mug, and it smashes into pieces. Pour cream into a hot cup of coffee, and watch it dissolve into a soft, warm cloud. Set a candle burning, and observe it melt down into a flat pool of wax. You have witnessed all of these things happen countless times, and you have never, not even once, seen any of them run in reverse. You have never watched fragments leap off the floor and fuse back into a mug. Never seen a swirling brown cloud pull itself back into a clean white ribbon of cream. Never seen melted wax climb back up a candle wick. Here is where it gets strange. Almost none of the fundamental laws of physics actually prohibit these reversals. Newton's equations, Maxwell's field equations, even the core formulas of quantum mechanics, run the mathematics backward, and they hold up perfectly. On paper, a smashed mug rebuilding itself is entirely legal, and yet it never occurs. Not once across the entire observable history of the universe, which means something else is doing the prohibiting, something larger than any individual law. This puzzle actually carries a name. Physicists refer to it as Loschmidt's paradox, named after the 19th century scientist who first raised it directly with Boltzmann himself. If the microscopic laws are time-symmetric, why does the macroscopic world run in only one direction? Boltzmann's answer, the one that still holds today, was not a new law. It was a fundamental shift in thinking, from asking what is forbidden to asking what is likely. Nothing prohibits the reversed version. It is simply buried beneath odds so lopsided that across the entire history of the universe you would never expect to witness it even once. So the real question is not whether God can do impossible things. Omnipotence, by most serious definitions, was never meant to include logical contradictions. Even the oldest theologians accepted this. A being cannot produce a square circle. That is not a limitation on power. That is simply what the words square and circle mean. The genuine question is this: is altering the past, like producing a square circle, a meaningless request dressed in the clothing of a hard one? Or is it something different, a perfectly coherent request that is physically blocked, the way you are physically blocked from outrunning light? Those represent two entirely different categories of impossible. And physics, not philosophy, is what tells you which category you are actually dealing with. Theologians wrestled with this precise distinction centuries before thermodynamics was a field of study. Thomas Aquinas argued that omnipotence means the power to do anything that is intrinsically possible, and that a God's inability to produce a logical contradiction is not a weakness, because a contradiction is not a thing at all. It is simply a string of words that cancels itself out. Descartes pushed back, insisting that even logic itself yields to a truly infinite power. That argument has never been resolved. But notice what it depends on: whether reversing the past resembles defying a law of physics or resembles uttering a contradiction. You are about to see the argument for the second one. The easy answer most people reach for is causality. Cause comes before effect. You cannot fire the arrow after the target already has a hole through it. Alter the past, and you would be rearranging causes after their effect have already taken place, which sounds like nonsense. That reasoning is valid as far as it extends, but it is not actually the deepest answer. Here's why. Causality on its own does not explain why the past is fixed while the future remains open. In Einstein's equations, time does not even flow. It simply exists, a fourth dimension laid out alongside length, width, and height. Nothing in the raw geometry declares that yesterday is sealed and tomorrow is available. Physicists call this picture eternalism, or more informally, the block universe, the idea that past, present, and future are all equally real and equally existent, the way London and Tokyo both exist right now, even though you are standing in only one of them. From this perspective, now is not special to the universe. It is special to you. The same way here is special to wherever you happen to be standing, without meaning every other location has ceased to exist. If that picture is accurate, then the past has not gone anywhere to be changed. It is simply not where you currently are. So if the equations themselves are symmetric, if physics does not favor forward over backward, then something else, something not written into the foundational laws, must be doing the real work of sealing the past shut. That something has a name. It is entropy, the second law of thermodynamics. And it is, without exaggeration, the only law across all of physics that points in one direction and refuses to point in the other. Entropy is a measurement of how many ways the interior of a system can be rearranged and still look identical from the outside. A shattered mug carries enormous entropy. There are billions of ways those broken pieces could be scattered, and it would still just look like debris on the floor. An intact mug has almost none. There is only one configuration that counts as a mug. So when the mug breaks, it is not fate, and it is not a law reaching down to forbid reassembly. It is simply overwhelming probability. There are astronomically more ways to be broken than to be whole. Here is the crucial turn. This means the flow of time you experience, the feeling that the past sits behind you and remains fixed, is not actually a fundamental feature of the universe. It is a statistical illusion constructed from trillions upon trillions of collisions, all leaning the same direction, like a massive crowd surging toward an exit. No single individual in that crowd is forbidden from walking backward, but the crowd as a whole moves one way. The past is not sealed by law. It is sealed by odds so enormous they function as one. And once you see it that way, the question about an all-powerful being stops being theological. It becomes a question about probability operating at a scale no mind, however powerful, can outpace. Physicists have actually tried to imagine a being clever enough to beat those odds. Not an omnipotent one, just an extraordinarily intelligent one. In 1867, James Clerk Maxwell proposed a thought experiment now known as Maxwell's demon, a tiny, quick-acting creature positioned at a gateway between two chambers of gas, sorting fast-moving molecules from slow ones, and in doing so apparently reducing entropy for free, seemingly without cost. It took more than a century to fully understand why this does not actually work. The demon must gather information about each molecule in order to sort it, and the physical process of storing and later erasing that information costs energy and produces entropy of its own, a result known as Landauer's principle. The ledger balances in the end. Even a being capable of tracking and sorting every particle individually still could not cheat the total. If sorting molecules carries this kind of cost, reconstructing an entire vanished moment of history represents a problem of an entirely different magnitude. Picture this scenario. A glass of fresh milk tips over and spreads across a kitchen floor. Roughly a trillion molecules scatter into a puddle in a specific disordered arrangement. For an all-powerful being to alter the past and restore that milk to the glass as though nothing happened, it is not enough to wave a hand and move the liquid back. Every single molecule must be returned not merely to the glass, but to its precise original position and its exact original velocity, correct to the last decimal point. Deviate by the tiniest fraction on a single molecule, and you have not restored the past. You have created a new, distinct arrangement that merely resembles it. Now expand that scale. Not one glass of milk, but the entire universe as it existed 1 second ago. Every photon mid-journey, every atom inside your own body, every particle of light still crossing space from a star that collapsed before this planet formed. Changing the past is not a matter of moving one thing. It is a matter of specifying one exact state from among a number of possible states so vast that comparing it to all the grains of sand on Earth is almost an insult to the scale involved. It is not that no being is powerful enough to accomplish it. It is that accomplishing it barely holds meaning at that magnitude. There is an older thought experiment that sharpens this point even further. In 1814, the mathematician Pierre-Simon Laplace imagined a vast intellect, later nicknamed Laplace's demon, that knew the precise position and velocity of every particle in existence. Laplace argued that such an intellect could predict the entire future and reconstruct the entire past with complete certainty, because classical physics is deterministic. For 2 centuries, that idea stood as something like the ultimate ceiling on what perfect knowledge could achieve. But quantum mechanics quietly demolished it. Heisenberg's uncertainty principle establishes that you cannot, even in principle, know a particle's exact position and its exact momentum at the same time. Not because your instruments are imprecise, but because the particle itself does not simultaneously possess both properties with infinite precision. Laplace's demon is not merely impossible to build and practice. It is forbidden by the very universe it was trying to describe. And if perfect knowledge of a single past moment is already out of reach, perfect reconstruction of that moment is out of reach as well. Let's go deeper because there are actually 3 distinct barriers here, not one. And any honest examination of omnipotence must confront all 3. The first is the thermodynamic wall. As already established, entropy within a closed system never decreases. This is not a rule imposed from outside, like a referee's ruling. It is a description of what the overwhelming majority of configurations look like. Ludwig Boltzmann demonstrated that a low-entropy past is not fixed by decree. It is fixed by being staggeringly unlikely to have unfolded any other way, which is itself a puzzle cosmologists continue to debate. Why did the universe begin in such an improbable low-entropy state at all? But once it did, every subsequent moment is a walk down a slope of probability that does not reverse by chance. The past is locked not because reversal is forbidden, but because reversal is absurdly improbable. The second is the relativistic wall. In general relativity, the past is not even a single universal thing. Einstein demonstrated that simultaneity is relative. 2 observers moving at different velocities can genuinely disagree about which of 2 events occurred first. There exist solutions to Einstein's field equations, one discovered by Kurt Gödel in 1949, that mathematically permit closed time-like curves, loops in space-time that curve back on themselves. On paper, these allow travel into one's own past. But here is the detail physicists rarely emphasize. Every known solution permitting this requires exotic conditions never observed anywhere in the actual universe. Rotating universes, infinitely long cylinders of exotic matter, wormholes held open by substances that may not exist in any stable form. Stephen Hawking's chronology protection conjecture goes further, proposing that quantum effects would generate runaway feedback, an infinite buildup of energy at the precise moment any such loop attempted to form, destroying it before it could complete. The universe, in other words, appears to actively defend its own continuity. The mathematics technically allows it. The physics appears to dismantle it every time. And even within the rare theoretical frameworks where physicists allow closed time-like curves to survive on paper, a second guardrail waits. The Novikov self-consistency principle, which states that any events occurring along a loop back into the past must already be self-consistent. You could not use a closed loop to rewrite history, only to become part of the history that already existed. In other words, even the most permissive version of time travel in modern physics does not grant the power to alter the past. It only ever describes a past that was, from the very beginning, already looped. The third is the quantum wall. Even at the smallest scales, where certain interpretations allow strange retrocausal correlations, measurements that appear to influence outcomes attributed to earlier moments, No experiment has ever produced usable macroscopic information flowing backward in time. The correlations dissolve the instant you attempt to extract a message from them. Nature appears to permit backward whispers into mathematics, while categorically forbidding backward shouts.